Hello everyone, and welcome back to Quest. Ever since you were a child, you've probably looked up at the night sky and seen it, that familiar glowing orb, the moon. It's been a source of myth, a beacon for navigators, a goal for explorers. But how much do we truly know about our closest celestial neighbor? It's more than just a big, bright rock floating up there. It's a dynamic, complex world with a history deeply intertwined with our own. The moon is slowly abandoning us. It quakes and shivers, it holds frozen secrets in its darkest craters. Let's start with a fact that sounds a bit like a cosmic breakup. The moon is slowly drifting away from us. That's right, our loyal companion is gradually increasing its distance from Earth. Every year, the moon moves approximately 3.8 centimeters. That's about the same speed at which your fingernails grow. The culprit is the very same force that gives us our ocean tides, gravity. That watery bulge then exerts a gravitational pull on the moon, tugging it forward. That tug gives the moon a small energy boost, causing it to spiral outward into a higher, more distant orbit. As the moon gains energy and moves away, the Earth loses rotational energy. That means our days are actually getting longer. When the moon first formed, a day on Earth was likely only about 5 hours long. Now our days are 24 hours. So, the next time you wish for more hours, thank the moon as it continues its slow, majestic journey away from us. Today, we're going on a cosmic journey to uncover 10 mind-blowing facts about the moon. If you're excited, hit that like button. And if you haven't already, subscribe to Quest and ring the notification bell. The universe is waiting. Let's get started. We're used to thinking of the moon as a dead world, geologically inactive, silent, and still. But the reality is far more dynamic. The moon experiences its own version of earthquakes, which we call moonquakes. These seismic events were first detected by the Apollo astronauts, who left seismometers on the lunar surface between 1969 and 1972. For years, these instruments listened to the faint rumblings of the moon, revealing a world that is anything but quiet. They recorded thousands of quakes. These moonquakes come in a few different flavors. Some are caused by the thermal expansion and contraction of the frigid lunar crust. Others are the result of meteorite impacts, sending shockwaves rippling through the rock. But the most fascinating and powerful quakes are the deep ones, occurring hundreds of kilometers below the surface. The Apollo seismometers recorded some moonquakes that caused the entire moon to ring like a bell for over an hour. When you look up at the full moon, it appears as a perfect glowing circle in the sky. But our eyes are deceiving us. The moon is not perfectly round. In fact, it's slightly squashed, more like a very, very subtle egg or a lemon. When the moon was young, its crust was still molten and malleable. The powerful gravitational pull of the Earth tugged on it, stretching it out of shape. Then, as the lunar crust cooled and solidified, this shape was frozen in place. For decades, scientists believed the moon was bone dry. But in the darkest, coldest corners of the moon, in craters that have never seen sunlight for billions of years, we found definitive evidence of water ice. These are among the coldest places in the solar system. Temperatures drop as low as -250 degrees Celsius. In these perpetual freezes, water molecules can stay trapped and frozen for billions of years, likely delivered over eons by comets and asteroids. Water can be broken down into hydrogen and oxygen, supplying breathable air for astronauts and the components for rocket fuel. These frozen craters could become cosmic refueling stations, a stepping stone to Mars and beyond. But the cosmos is full of surprises, and the moon's story is far more dramatic than these quiet ice deposits suggest. Our celestial companion has a violent past written in its very existence. The leading theory is the giant impact hypothesis. It says the moon came from a cataclysmic collision between proto-Earth and a Mars-sized body. Picture the scene. About 4.5 billion years ago, Theia slammed into the still-forming Earth in a glancing blow. The impact was unimaginably energetic, more powerful than billions of atomic bombs. It vaporized Theia. It blasted a huge chunk of Earth's mantle into space. All this was thrown into orbit around our wounded planet. Over time, gravity acted on the orbiting ring of debris. Within a few thousand years, a blink in cosmic terms, the moon had formed. This explains why the moon's composition matches Earth's mantle. When we talk about an atmosphere, we think of the thick blanket of air that surrounds Earth. The moon, for all practical purposes, doesn't have one. However, it's not a perfect vacuum. The moon is surrounded by an incredibly thin, tenuous layer of gases scientists call a surface boundary exosphere. The density is minuscule, roughly 100 trillion times less dense than Earth's atmosphere at sea level. That's why the lunar sky is always black, even in daylight. One of the most famous facts about the moon is its low gravity. The moon's gravitational pull is only about 16.6% of Earth's. If you weigh 180 pounds, you would weigh a mere 30 pounds on the moon. That's why astronauts, even in bulky suits, could leap and bound across the lunar surface. A simple hop could send them soaring several feet into the air. But it's not just fun, it has big implications for engineering. You could lift objects 6 times heavier than on Earth. However, long-term stays would lead to muscle atrophy and to bone density loss. The 1/6 gravity rule is a fundamental part of the lunar environment, shaping how you walk and how you might build a future home there. But perhaps the most fascinating aspect of our relationship with the moon isn't what we've discovered about its interior or its composition. It's what we see every single night and what we've left behind that will outlast civilizations. Have you ever noticed that no matter when you look at the moon, you always see the same pattern of craters and seas? The moon is tidally locked with Earth, which means it rotates on its axis in the exact same amount of time it takes to orbit our planet. There is a whole other side of the moon, the far side, hidden from Earth. On July 20th, 1969, Neil Armstrong and Buzz Aldrin left the first human footprints on another world. Those footprints are still there today, and they will remain there, almost perfectly preserved, potentially for millions of years. The moon has no wind to blow away the fine lunar dust, no water to wash the tracks clean, no significant geological activity to pave over the landing sites. For anyone who has spent time by the sea, the rhythmic rise and fall of the tides is one of nature's most powerful and predictable cycles. The primary driver is our celestial neighbor, the moon. It acts as a cosmic puppeteer, pulling on the strings of our planet's vast bodies of water. The water closest to the moon is pulled towards it most strongly, creating a high tide bulge. But a second high tide bulge is created on the opposite side of the Earth. When the sun, Earth, and moon are aligned, their gravitational forces combine to create extra high spring tides. When they are at right angles, their forces partially cancel each other out. And there you have it, 10 incredible, mind-bending truths about our constant companion, the moon. The moon is so much more than a simple light in the night sky. Which of these lunar facts blew your mind the most? Let me know your favorite in the comments below. If you enjoyed this journey and want more, subscribe to Quest. Turn on notifications. Until next time, stay curious and keep looking up.